So let's have a look why splitting your training data is a requirement in machine learning. So consider your complete training data set. If you train a machine learning algorithm on your complete training data set, you eventually will be very lucky because you get really good results. But now what happens if you show unseen data to the same algorithm which you have been trained? You most probably will see very bad results. So let's consider a classification and a regression example. On the left hand side you see a classification boundary. So what do you think, which of those two lines are good classification boundaries? So one line tries to classify each and every data point correctly. On the other hand, the other line is not. The same thing in regression. One line tries to match each point correctly, and the other one is just a straight line which somehow matches all the points but not very precisely. So we call this process overfitting, but more on this in a second. In order to prevent overfitting, a good practice is to split your training data into two sets. One remains called training data, the other one is called validation data. Good splits are, for example, around 70 or 80% training data and 20 or 30% validation data. Now, if your trained machine learning model does a good job on the training data, and on the other hand, on the unseen validation data also does a good job, we are doing everything exactly right. But now let's consider we are doing a good job on the training data, but a bad job on the unseen validation data. This is called overfitting, because we are fitting the model too strongly to the training data, and therefore it's not generalizing good enough to unseen data. On the other hand, if we are doing a bad job on the training and on the validation data, we call this underfitting. So in summary, to make sure that your model is doing a good job on unseen data, it is essential that you split some data apart from your training data, call it validation data, and have a look how your trained model performs on that validation data. If it performs more or less the same than on the training data, you are doing everything exactly right. If it doesn't perform on the validation data, but it performs on the training data, you are overfitting. And specifically for each machine learning models, there are some parameters you can tune in order to prevent overfitting, and we will cover those for each and every individual algorithm.